Alright, Chapter 2, Description of Equipment, Section 1, Boilers and Heat Exchange, Boiler Classifications. There are a few fundamental types of the boilers, mainly variation each of the type of the boilers are generally classified according to the relative position, combustion of gas and water with either the fire tube or the water tube. Boilers are also classified by form of the energy produced, lower, higher pressure steam, lower, medium, high temperature water. Other methods of classifying boilers are listed: type of the water, circulation, natural certification, forced circulation, type of steam producing, saturated, superheated method, assembly package, modular fire, field directed, type of use, stationary, marine, power, heating, type of fuel, coal, oil, or gas, method of combustion, speed, stroke, or fetalized bed, and pulverized coal. Boiler capacity up to 20,700 pounds per hour, up to 600 horsepower for the fire tube of the boilers, up to 10 million pounds per hour for the water tube of the boilers, up to 200 million pounds of the British thermal units per hour of the hot water boilers. Alright, 2.2 Boiler Design Requirements. Boiler must meet the following requirements: operational safety, generating of clean steam in the hot water is desired rate with the pressure and temperature of the economy of the operation, maintenance, the conformance to applicable codes. A set rule for the construction and operating with the boilers known as the American Society of Mechanical Engineers Boiler Pressure Vessel Codes has been widely adopted in insurance for under the right of the government agencies. Section 1 of the code contains the requirements for power boilers, include methods of construction, installation, material to be used, accessories, inspection. Section 4 of the code contains the requirements for heating boilers. Low pressure steam boilers, low temperature water boilers are classified with the heating boilers. Section 6 of the code provides recommended rule for the care of the operation heating of boilers. Section 7 provides the recommended rule for the caring of the pure power boilers. Other sections of the code provided with the material specification, nuclear requirements, inspections, welding qualifications. To meet the above listed boiler must have the following characteristics: adequate water steam capacity, properly sized steam water separated for the same boilers, rapid positive regular water circulation, heating surfaces which are easy to clean on both water and gas size, partially accessible, inspection, repair, correct amount with the weight, proper arrangement of the heating surfaces, furnace of the proper size, shape, and the efficiency of combustion directly with the flow of the gas, efficiency, heat transfer. Alright, 2.3. All boilers, superheater that economizes for the other pressure for the parts must be built using materials construction methods specified in applicable code. Section repair of the boilers must also be made in accordance with the code of the requirement. Equipment built and inspected with the corners for the code must have the American Society of Mechanical Engineers stamp, an H, and the cloverleaf, the stamp for the heating boiler, and S is the stamp for cloverleaf, the stamp for the power boilers. Drums and shells and headers. The boiler drums and shells and headers are used to collect steam of the hot water with the generator of the boiler, distribute the necessary of the boiler tube. The connection must be strong enough to contain the steam of the hot water and generated to the to mechanically hold the boiler tube, then to expand contract to change the temperature of the shells. Also, fire tube boilers will be reinforced by the use of stay holes for the boiler heads in place. The components are generally fabricated with welded seam connection. Riveted seams are no longer used. Although many old riveted boilers are still operational. Boiler tubes carry water, steam, and fluid with the gas of the boiler. The boiler tubes are installed with expanding the welding that is seated within the drums. The header of the expander tool consists of the tapered pins within fits for the cage containing several small rollers. All the different sizes expanded with the required for each of the size of the tube. During the installation, the expander is slipped with the end of the tube, tampered with the pin, pushed into the cage until the rollers against the tube with the wall. The pin is turned in with a wrench for the motor facing the rollers out against the tube, with the simultaneously moving the cage into the tube where the action distorts the stretch of the tube, the forcing making the tight seat against the tube seat. The expander often stops that helps to prevent the overlapping. As shown in Figure 2.1, the boiler tubes are installed with the end of the projecting slightly beyond the tube sheath. Projection ends with a fairly slighted water in the water tube allowed to remain because the surrounding the cooled by the water and steam. Since the tube ends with the fire tube of the boiler are surrounded with the hot gas, they would be soon burned off if allowed to project. They are threaded. They are therefore better than hammered until the fan flat against the tube sheet. This process allows the hand holding of the tube is most, however, performed carefully to avoid injuring the tube. However, here's two tubes to illustrate the flared and beaded tubes. See, baffles or thin walls of the partitions installed with the water tube boilers direct the flow of the gas over the heating surface in the desired manner. The member of the position of the baffles have marked in effect for the boiler eventually leaking. The missing baffles permits the gas with the short circuit through the boiler's heat, which shall have been absorbed by the water when it dissipated with the loss with the leaking of the baffle doubles and the damage for the hot blowtorch action of the flame hot gas the sweeping across the tube at the higher velocity, especially in the leak of the near the furnace. Baffles should be made of the iron cast sheet metal strips, brick tile, plastic plastic refractory. Provisions must be made to permit the movement between the baffle and the seating of the wall. While the sitting still maintaining the gas-tight seal, the iron castings are made with a long, narrow section and to fit with the two blades around the tubes. They can be installed only while the boiler is being erected and assembled. There is used in limited by temperature, which they can withstand. The sheet metal are formed to fit around the tubes, so they easily are installed after the tubes are in the boiler. The primary uses are to help the distributed flow of the gas with the pass of the maintain the proper tube spacing rather than the function of the baffles between adjacent passes. The type of the baffle cannot be used with the high temperature of air of the boiler. Brick or tile baffles are made specifically shaped within the fit of between and around the lathe tubes. Can be installed after the boiling here being erected. Can only be used in the air of the boiler. Castability of the plastic refractory bowl baffles are usually installed with the molding of the form. Pouring of refractory like of the concrete, the form of the removed from the factory as said, but the type of the baffle can be used on location and the boiler properly designed can remain with gas tight for long periods. It may be used to repair and replace other type of baffles. Alright, 2-4 fire tube boilers. Many of the first steam boilers produced was designed with the product of the low combustion inside the tubes. Fire tube is designed to develop primary through the direction of Scotch type of the boiler shown in Figure 2-3. The Scotch boiler is fabricated one capable of supplying saturated steam at the pressure below 250 psi at the capacity of 20,000 pounds per hour with the pressure at 250 psi. Natural certification water steam. The design was not adequate with good heat transfer. Capacity above 20,000 pounds. Shell diameter becomes too large. The economically Scotch boilers come in 2, 3, and 4 gauge gas pass designs. Illustrated in Figure 2-4. The more gas passages, the more heat transfer surface of the boiler exists. Half the temperature low, efficiency higher. Wet back construction. The Scotch boiler means the water will provided at the outlet of the first pass for the furnace. Wet back construction reduced with the high temperature, high maintenance costs often associated with the dry back design. Scotch type of the fire tube can effectively fire natural gas, fuel gases, and coal, lessly desired fuel because of the fire tubes cannot easily clean. Ash removal restricted. Advantages of the switch boiler include the ability to respond to rapid load swings due to the large volume of the stored water, steam, and shell, and low initial costs and low maintenance costs and low general ease and over control disadvantage. They include the difficulty proceeding superheated steam, the pressure capacity limitations. Scotch boilers are also used to produce low temperature water, but the other common type of the fire tube boiler is a horizontal return tubular or HRT design, as illustrated in Figure 2-5. The firebox of the type of the boiler permits the burning coal, losing stokers, and fluid beds. 2-5 water tube boilers. Water tube boilers developed a variety of reasons, including the need of the high pressure, the higher capacity superheated steam, faster response to load hinges, increased safety due to the reduced water volume. The water of the tube of the boilers have water inside of the tube. The flow gas on the outside of the early straight tube design will be replaced with the today's cement tube design to increase the amount of available heat transfer surface to solve the mechanical problem. General economic reasons. Figure 2-6 illustrates a 4-drum boiler with the water-cooled back wall of the bottom drum. Drum is called the mud drum because of the tendency of the boiler sludge to collect in the low area. The upper drums are called the steam drums. Water enters the top of the rear drum, passes through the tube at the bottom of the drum, and then open the tube of the two front drums. Make sure the steam and the water discharge into these drums. Steam return to the top of the rear drum through the upper row of the tubes while the drum has traveled through the tubes and lower rows. The steam is not removed near the top of the rear drum. The dry pipe is extending with the excess of the drum and discharged through the steam outlet header. The baffles are arranged and encourage flue gas flow over the boiler. Figure 2-1 shows a tube expander. Figure 2-2 shows flared and beaded tubes. This and not this. Flared tube. Beaded tube. Tube sheet. Beading a tool. Beading tool. Figure 2-3 shows a Scotch boiler. Figure 2-4 shows the 2, 3, or 4 pass Scotch boiler design. 2 passes. 3 passes. 4 passes. Figure 2-5 shows a horizontal return of the tubular boiler, boiler output. As you can see, the arrows going through the passes of the boiler. This is a 4-drum water tube boiler. 1, 2, 3, 4. Tubes of good heat transfer from the drum boilers have generally placed 3 or 4 drums in the unit for the modern construction because of the less expensive construction. Refractory furnaces, each of the boilers designed utilized with the refractory furnace of the combustion zone. Some of the furnaces have been used for the arc of the bridgeways to reflect the heat to maintain high temperatures in the specific zone for the burning of the anthracite, other hard coals. Some of the prolonged exposure, high temperature damage the refractory material necessary to maintain heat liberation between the BTUs per hour per cubic foot of the furnace volume. The reference of the refractory furnace within the reasonable limits depend upon the type of the refractory, type of the fuel firing method, type of the heating surface expanded with the radiation heat, and the type of the cooling mechanism. The minimal maximum heat liberation rate of the refractory furnaces ranges from 25,000 to 35,000 BTU per hour per cubic foot. For a full load refractory wall construction, it is important to allow the thermal expansion of the curve of the refractory heated with the operating temperature. Figure 2.7 illustrates the typical expansion joint arrangement for development of the alumni super duty firebrick insulated firebrick block insulation castability refractory plaster refractory and having greatly improved refractory life with the reduction radiation loss of the boiler furnace of the Navy Flax Center heating of the plant MO 205 discussing refractories in greater detail. Water wall construction. Water walls are developed to allow the use of the higher firing rates of the higher furnace of the heat, the release of the rates, while reducing the heat loss for the maintenance improvements of the water wall furnace and associated with the casting lagging to reduce the infiltration of the boiler, reducing excessive air levels, improving the boiler efficiency. The 4 types of water walls construction are tube tile and tangent tube and sub tube and a membrane wall. The tube tile construction, which was developed and provided only with the partial solution maintenance of the heat loss problem. Minimal electrical tube spacing is limited in the ability of the economically roll of the tubes into the drum header. This in turn limits the amount of the heat transfer to the surface area, the amount of the protection given in the factory, and the limits subjectively of the tangent tube. This construction studied tube of this construction when developed was the highly effective in an area of the heat with the reliefs. This is hot bridge walls and arches sub tubes covered with the refractory explosive, especially effective. Flue gas can be still leak with the through stub wall tube wall construction under some of the circumstances resulting corrosion. Boiler tubes lagging to obtain completely gas-tight construction, maximize heat transfer. Membrane wall construction was developed and remains best of the most expensive water wall design. Or steam drum internals. Steam drums are equipped with mechanical separators to ensure the steam leaving from the boiler does not contain solids or any other impurities. The steam-free water is made but then continue the natural circulation process into the boiler. Dry pipe earliest device was placed inside of the shell drum just below the outlet nozzle. Numerous manholes drilled the upper half of the dry pipe to cause the separation from the aim of the water intended with the boiler designed toward the higher heat transfer of the race, making separation from the water steam more difficult. Limits of the application of the dry pipe. Combination of baffles silicone type of the separated with the corrugated scrub of the perforated plates and now used for the effective separated with the water steam. Figures 2.9 illustrates the modern steam drum interval. The cyclones are arranged with the row and receive the water when the steam mixture tangible with the boiler water wall and generated the tubes. The water is spun into the outside of the silicone existing with the open the bottom of the cyclone. The steam is less dense and thus stays center of the axis existed through the open top cyclone. Scrubbers further reduce the amount of water entered in the solids and steam from the water. Well designed steam drum should be less than 3 ppms. Generating surface. Boiler tubes that connect the upper lower drums are called generating surface. They are included with the water wall surface when computing with the total heating of the surface that may differ from the tube spacing depending on the type of the fuel being fired. Tubes may align to stagger. The staggered tube arrangement would not be acceptable for the coal, heavy oil fire boilers. Do acceptable to use ash buildup, however, that provides better heat transfer to the gas and light oil units. Superheater. Some of the process turbine require the steam of the superheater above the saturated steam temperature. Figure 210 to illustrate the 2-drum boiler equipped with a superheated water wall spread stroker economizer. The steam of the steam drum is directly to a superheated inlet heater through the superheated tube to the outlet heater. With the steam outlet of the superheater can be arranged in many ways. May be located behind the row of the generating tube. The tube cool surface is somewhat the reaching of the superheater tube so shield the superheated tube from the radiant heat. Superheaters are not commonly found in the Army Central boiler plants. Alright, F. Package boilers. Package water tube boilers are factory assembled and complete with the combustion equipment, the mechanical draft equipment, automatic controls, and accessory. The factory assembled the package can be purchased with a capacity of 200,000 pounds per hour. Package boilers available with the three basic configurations D, A, and O. The figure illustrates the D, the type of the boiler arranged with the oil and gas firing. Note. Note that the flame travel lengthwise the furnace with the combustion glass, the flue glass with the make of the 180 degrees turn the comeback to burn or the burner boiler existing from the side with the great generation bank tubes. Historically, the package of the boiler have been designed for the fire only natural gas oil. Cool firing has not only been practical due to the high ash content with the cool, but the wood which would plug the boiler generating banks. Package boilers have been widely successful applied to the central boiler services. Alright, this shows the corner construction with staggered expansion joints. 18-inch wall. Floor-to-wall expansion joints. 2-7 refractory expansion joints. Your tube and tile, outer steel casting, insulation blocks, metal lathe. Plastic insulation, shaped fire bricks, plastic insulation, metal lathe, insulation block, outer sheeting, steel casting. Tangent tube, plastic insulation, heavy steel casing, insulation blocking, light steel casing. Stud tube, chrome, plastic, or natural slag, metal lathe, plastic insulation blocks, outer steel casting. Membrane wall, outer steel lagging insulation block, water wall construction, figure 2A. Alright, this is 2.9 steel drum internals. You have a corrugated scrubber cyclone separator and a baffle. The corrugated scrubbers, perforated distribution plate, and drain pots. Or figure 210 shows a superheater and superheater to 2-drum boiler. You have your stack, your dust collector, economizer, gravity center returns to grate, induced draft fan, forced draft fan, stroker, ash hopper, coal hopper, superheater. Are your package boiler configurations? You have the D, the A, and the O. Package D package boiler. Alright, 2.6 hot water generators. Hot water generators are often called the hot water boilers, even though little to no boiling occurs. Modify the Scotch boiler, verifying the package boilers available. These boilers may limit uneven water circulation or characterize natural circulation utilized because of the small natural circulation force available to special boilers that has been developed for the use of the force to improve the heat transfer. Figure 213 illustrates the type of the hot water generator. To note the seam and the mud drums have been replaced with the header of the hot water generator connected with the hot water distribution system. As the water heated with the hot water generator, the water expands. The hot water distributed with the various heat with the exchangers illustrated in figure 2.4. The water cools. On contrast, expansion drum, the pressurized either the steam or the in-air gas provided with the adjustment of the volume with the change of one or more essential figure pumps is required to circulate the system. Figure 2.5 that illustrates the high temperature water system equipped with the steam pressurized expansion drum, circulation pump for the generated circulation pump for the distribution system. The other agreements are possible. More detailed description of the hot water generator distribution system provided with the Army Manual Technical Manual 58102 entitled the High Temperature Water System. Water heating system. 2.7 economizers are used to recover the heat from the boiler flue gases, thereby increasing the boiler efficiency. The heat absorbed with the economizer is transferred to the boiler. Feed water flowing through the inside of the economizer tube. Because the feed water temperatures are much more lower than saturated steam temperature and effective temperature of different existing. They enable the good heat transfer. The low economizer or existing gas temperature consistent tubes. So tube the construction is common. The bare tube the used for the coal-fired boilers with the fine tube. The expanding surface is commonly used on gas and oil-fired units. Figure 216 and 2.7 shows the continuous bare tube economizer. Figure 217 illustrates the steel fine extended surface economizer. The extended surface performance of the heat transfer from the gas by Providing more heat, surface care must be taken when selecting the number of the fins per inch. The extended surface economizes natural gas fired, but the boiler may be used with 9 fins per inch, while other 2 fins per inch, but they may be used with heavy oil-fired application provision for the cleaning in the soup boilers necessary, but the economizer coal oil-fired boilers economizer are usually arranged with the gas flowing down with the water flow up. The maximizing heat transfer helps avoid the water hammer. The economizer usually design water temperature below the saturated temperature of the water to avoid producing steam. The economizer should be equipped with a 3-valve bypass water system. Allowing surface to bypass the water lower boiler leads to help minimize the economizer corrosion. They will be high sulfur to fuels will burn. The figure 218 provides the curve with established minimum metal temperatures allowable corrosion protection with the economizer air heat. Since the water temperature of the economizer is normally 212 degrees Fahrenheit, the fuel sulfur content would have to be not less than 2% with the stroke fired with the coal and 2.6% oil fired boilers to minimize the corrosion problems during operation. Method avoiding corrosion during idle and standby periods discussed in paragraph 327. The economizer pressure part with the such must be a manufactured stamps in accordance with the American Society of Mechanical Engineering boiler vessel code. Economizer equipped with 3-valve bypass must be equipped with 1 more safety valve. Alright, 2A, air heaters. Air heaters, like economizers, are used to recover the free heat from the boiler, the flue gas there by increasing the boiler efficiency. Heat absorbed the air, heat and transfer the combustion air before the air enters the burner. The preheat of the air and not only improve the efficiency, recovering otherwise lost heat, but also can improve the combustion of some of the fuels, promoting higher furnace temperature. There are 2 general types of air heaters: recuperative air filters, and like tubular air heater illustrated in Figure 219. Transfer the heat from the hot flue gas on one side of the tube, the combustion air on the other side of the tube. The regenerative air heaters are like rotary wheels illustrated in Figure 220. Transfer the heat indication the heating of the plant with the hot gas, while then rotating the hot plate with the cool combustion air with absorb the heat. The rotary heat wall wheels are equipped with the cells separated with the flue gas of the side, combustion air side. With the wheels, any filtration from the air side with the gas side maximized, eliminated. With the side is a factory must be considered with the size force with introduced draft fans provision with the soup blowers are required to dirty high ash fuels before being fired cold. This picture is a hot water generator. This shows a hot water end uses. Unit hot water radiation panel, air conditioning steam producer, domestic water, hot water producer, expansion drum. Hot water distribution. Let's see which way it goes in. The hot water returned through the butterfly valve into the expansion vessel. It had 3 valves. One of the valves is open, and the other 2, another one on one circuit that goes back through butterfly system pump hot water system, which is also a return front line from the generator pump hot water generator, which has 3 and generator pump. The line between the expansion vessel and the generator pump also goes through make up feed water. (216) Bare tube economizer. Economizer outer heading. Economizer normal directional gas flow. Economizer inlet header. Outlet header. Inlet header. Alright, extending the surface of the principle of water flow, gas flow, extending surface of the economizer, cold end corrosion, minimal metal temperatures, sulfur fuel in percent by weight, and minimum metal temperature Fahrenheit from 440 to 290, and sulfur and fuel percent and weight is 0 to 6%. And corrosion is more of a problem than any air heater than an economizer because of low air combustion air temperature. Figure 218 establishes a minimum allowable metal temperature. If the corrosion can be controlled with the cold air passes the duct and damper the hot air recirculation. Steam coal air heaters, low-level customizers are examples of methods of preheating combustion air before it enters the air heat. The method can help control cold air erosions. Can also be reduced efficiency, but the system raising existing gas temperatures. Section 2, boiler accessories and fittings.